Hi, good morning to all. So finally we are live for lecture number 4. Yesterday was the World Cup semi-final, so we were not able to conduct the session. But finally India won the match and we got also the strategy for February 2024, right? So how we have to attempt gate examination, we got to learn from semi-final. In fact, for the final examination, right? And we will also see what kind of a strategy we have to get for final examination, right? From the final match, you can say. Right. So in this session, what I'm supposed to discuss here is please join the session fast, okay, so that we can start it. So today we will be talking about power, energy, and so on and so forth. Right. So in this session, what I'm supposed to talk here is the power and energy in an element, right? It is one of the important aspect of basic electrical circuit, power and energy in an element. Okay, that element can be passive. Okay, like it can be a resistor, capacitor, inductor. It can be, you can say, a voltage source or a current source, right? So how do we find out this power, energy? Okay, power and energy. It is very important concept which will be asked in your gate examination, right? So there are many concept. If you learn the concept, uh, yeah. If you learn the concept, then what will happen here is that you can solve any question in less amount of time. Fine. So first of all, let us appreciate this concept. What is this concept basically? Suppose we have got element here. Any element you see, this is the black box here, and suppose the current is flowing I, and the voltage across this is nothing but V, right? So how do we define the power? So basically, when current, you know, when current is entering to this element, right? So we can say that. We will say that the power delivered to this element, right? The power delivered, okay, to this element is going to be equal to what? The power delivered to this element is going to be V times I. The product of current and voltage is nothing but a power, right? Remember, power is always the unit of power. If I talk about, that is given in watt, right? Watt. It can be kilowatt, it can be, okay, so megawatt or something. So this is a watt, okay? Watt is the unit of power. So power delivered to this element is going to be VI. Okay? So if I talk about instantaneous power, so you can say that the P of t is going to be the voltage as a function of time and the current as a function of time, right? This is called instantaneous power. And then if suppose power is greater than zero, okay, suppose you are finding this VI and you got to know that yes, VI is positive, right? Power is greater than zero, you can say. So what you will say here is that power is greater than zero means the power is greater than zero means you can say that the element is absorbing power. Okay, element is absorbing power, absorbing power. And if power is less than zero, you can say if the power is less than zero, so element is delivering power. We call it element is delivering, okay, delivering power. Okay, these are very important aspects that you have to always keep in mind, right? So power and energy in an element means what? Power delivered to this element is going to be VI. If the power is greater than zero, element is absorbing power. If power is less than zero, element is delivering power. So these are the points that you have to remember. And if you know the passive sign convention says that if any passive element is there, so current will always enter to plus terminal of the, suppose you are specifying the voltage across the element. So the current is going to enter to the plus terminal of the element. So you can say that the power is going to absorb by that element, right? Okay. And if suppose voltage source is there and the current is flowing, like from minus to plus, so power is going to get delivered. Right? So you have to see always the direction in which the current is flowing. I mean, uh, with through what terminal the current is entering. If current is entering here, okay, so I will discuss this with respect to passive element and all, right? So I think this is clear. So if you know the power, so you can find the energy delivered to the element, right? So energy will be delivered to the element, which means some time interval, right? So you can say that initially you can compute the power. See, whenever they will ask question based on energy, right? So first of all, you compute the power, okay? Power delivered or absorbed by the element, okay? And then you try to find the energy, right? Then you try to find the energy. So energy delivered to the element is going to be what? Energy delivered. Energy delivered. Okay, this is very important aspect. So energy delivered to the element. Okay, in certain interval, you can say like, you can say that T1 to T2. So what you have to do, what should be your strategy? The very first thing is you can find out the power, then you can find the energy delivered to the element. How can you find the energy delivered to the element? They will ask energy delivered to the element in this interval T1 to T2, right? So you can say that it will be nothing but the area under T1 to T2, okay, like area under this interval, you can say, right? Area under this power delivered okay, power delivered to the element, that element can be anything, right? Okay, and dt. So you just find out the power, okay? So you can say that here T1 to T2, right? T1 to T2, Vt times It dt. So just what you have to do, you have to just integrate power, right, in that interval. That's it. Okay. So this is how we can find out the energy delivered to the element, right? So you have to understand when energy is delivered, when energy is absorbed, right? So this is how we find the energy, okay, of any sort of element. So in future, in case of transient analysis and all, you'll see that, okay? So let us take n-terminal element. Suppose we have got n-terminal element, n-terminal, okay, element. So when we talk about n-terminal element means what? We need to take this black box, okay? Black box only will be there, n-terminal, right? So there are n number of terminals. You can say 1, 2, and so on. There are n number of terminals, okay? And suppose one terminal is there where current is flowing I1. Second terminal is there, you can say the current is flowing I2, right? And the third last terminal you can say is there, the current is flowing what? IN. Current is flowing IN. So all the current are entering to the like in this black box, right? So you can also take one reference. See, whenever you will specify the voltage here, right? Remember, this is very important. Whenever you will specify the voltage, right? You need to take one reference. One reference would be there, okay, in order to specify the voltage, because in future you will apply the nodal analysis, right? Nodal analysis. So at that point of time, you have to always, whenever you are writing the voltage and the current relationship across any element, right? Or you have to always take the reference. Don't forget to take the reference. The reference is very, very important. Reference you can take as a ground, okay? That is one of the best readily available reference, right? So this reference should be there. So you can say that for first terminal, this is the voltage that appears to be at this terminal V1, and the voltage appear for this, you can say V2, okay, for second terminal, and for last terminal you can say this is the voltage Vn, right? I hope it makes sense. Okay, so this is the n terminal element. So if I ask you what is the power delivered to this element, right? The power delivered to this element, right, which is a n-terminal element. This is n-terminal element. I'm just showing you in general, right? So as I promised that I'm gonna give you generalized understanding, right? So if there are n number of terminals, all the voltages, all the currents, okay, through the terminals, at the terminals, right, with respect to reference and all, you can find the, so this terminal will be having, you can say that V1 times I1, V2 times I2, Vn times In. So you can say that you will be getting a sum. Okay, you have to sum it. Vk times Ik. You can say Vk times Ik all the terminals. Right. all the terminals, right? So you have to just add all the powers, that's it. Okay, v1 times i1, v2 times i2, and so on and so forth, right? So you can say that it is nothing but what? You can say v1 i1 plus v2 i2 plus v3 i3 and so on plus vn in. Okay, vn in. So this is very important, and don't forget to take the reference. This is one of the primary mistake everyone does. Reference is always important while solving the circuit, right? So whenever you are specifying the voltage, so it should have some reference. Okay. So as I said that if somebody is going to ask you, suppose you have got n terminal element like this. Okay, suppose you have got this kind of question also has been asked in the gate examination, right? Suppose you have got n terminal element like this, right? So current you know is I1, current you know through this terminal is like 1, 2, 3, and you know the current through this element is n, I mean IN, and the current through this element if somebody is going to ask, so you will say n minus 1, right? This is n minus 1 terminal, okay, and so on. So many terminals are there? There are n number of terminals you can say, right? So what you can talk about here is, suppose somebody is going to ask you, can you find out what is the value of IN here, right? See, suppose you know all the currents through each terminal, right? And if someone is going to ask you what is the value of this IN, right? IN. How can you find that? Okay, so this kind of question also has been asked in the gate examination, right? So they gave two networks here. Okay, so one current is going, then what will be the current? Okay, through another terminal, right? So this is in general understanding, right? If you know this, then yeah, fine. So what you can do here is this is n terminal element, right? So you can apply the KCL. You can take this as a closed, closed surface, right? You just take as a closed surface here, right? So you can apply, all the currents are entering to the node, you can add them. So I1 plus I2 plus and so on plus IN minus 1 plus IN equal to 0. So now you can find this IN. So IN is going to be what? IN will be minus time. Okay, sum of all. Sum of all. See, the current, suppose sum of all the current is going to return to this node. Okay, you can imagine like this, but both IN and the return current is going to be opposite to each other. So we are putting minus sign. We can say that I1 plus I2 plus and so on plus IN minus 1. So guys, you can take a look at PYQ, the previous question, right? And you will be able to find the, you will be amazed to see that, yes. So these are the generalized understanding that you have to take away. And from the last semi-final, World Cup semi-final, we have got to see the strategy, right? How we have to attack for the main examination. You have to manage everything at the same time, right? You have to manage the pressure. Okay, the pressure can be managed if you're already having all the equipment, okay, to solve the questions, right? Please remember this. Okay, so this is all about, suppose you have got n number of terminals and all the currents through the terminals. One of the current is unknown. You can find out the current by considering entire black box as a closed curve. Okay, you can apply the KCL over there, right? So KCL is one of the versatile law that you can apply. Okay, and you have to make sure that the KCL should not be violated as well, right? So I think this is clear. I think this is clear. So this is all about power delivered. And so if I talk about power energy in the resistor, let us talk about power energy in the resistor, because till now I have been talking about power and energy concept in the black box, but let us talk about power and energy in the resistor. Okay, basically what resistor does, okay, like whether it dissipates power or stores power, that we have to see here, right? Resistor is nothing but a device, which opposes the flow of current. Everybody knows, right? So certainly there will be a power dissipation if you oppose something, right? Suppose somebody wants to do something and you are opposing that, right? So definitely there will be some sort of a power dissipation. Okay, so what kind of so if I talk about the symbol of that resistance, so resistance look like this, you see. and the current is flowing I here, the voltage across is going to be V, right? So we are considering the passive sign convention here. We are considering that the current is entering to the plus terminal, so that we have to make sure, right? So here you can say that the P power is going to be product of the voltage and current, okay, across any element. So from the Ohm's law, you know that V is equal to what? What is the relation between V and I? From the Ohm's law, that is V equal to IR. So here you can plug here I times R. So it is nothing but I square R. So this is the power that you have to keep in mind through the resistance. Okay. So I square R. Suppose R is 1 ohm. So you can say that power is going to be I square simply, right? The current is square, because in signal and system, when we define power, right? Suppose we want to find the power of the signal, right, or the energy of the signal. So what we do over there is we always normalize resistance as 1 ohm, okay, and then we take, suppose signal is in the form of current or a voltage, so we take x square t and integrate it, right? So we get the power or energy, right? Okay. So if the signal is periodic signal, so we always find the energy in one period and then divide by the time period, okay, in case of signal and system, right? So from where those formulas are motivated, those formulas are motivated by these electrical elements, electrical circuits, okay, whatever we study here, right? Always see what is the connection, right? Whatever you learn the concept, you see the connection, okay, from where this concept has been originated, right? So it will help you to understand, because I have seen many people, what they do is they'll remember the formula, right, and they do not know how to use that formula. Suppose some minor change has been made in the question, gone, right? ठीक है, तो मैंने देखा है बहुत सारे ऐसे टॉपिक हैं जो मैं आपको लास्ट में बताऊंगा कौन कौन से टॉपिक हैं, इन मैथमेटिक्स, इन कम्युनिकेशन सिस्टम, राइट? अब कम्युनिकेशन सिस्टम में सिंपल सा क्या पूछ रहा है, एक रिसीवर सिस्टम दिया है, डिजिटल कम्युनिकेशन सिस्टम दिया है रिसीवर का, और उसके बाद वो पूछ रहा है कि व्हाट विल बी द ऑप्टिमम थ्रेशोल्ड वोल्टेज, राइट? और बाइपोलर पल्सेस गिवन है, गॉसियन रैंडम वेरिएबल है, मतलब AWGN नॉइज दिया हुआ है, वेरिएंस दिया है, प्रोबेबिलिटी ऑफ गेटिंग 0 सम दिया है, प्रोबेबिलिटी ऑफ गेटिंग 1 समथिंग दिया है, बस उसका आपको ऑप्टिमम थ्रेशोल्ड वोल्टेज निकालना है। तो अब अगर आप डेरिवेशन करने बैठोगे तो बहुत टाइम लगने वाला है, राइट? सो यू शुड नो, ओके, व्हाट इज द मीनिंग ऑफ ऑप्टिमम, ओके, ऑप्टिमम, राइट? तो चलो, तो ये रेजिस्टेंस है, यू कैन सी द पावर इज गोना बी व्हाट, I square R. नाउ यू कैन आल्सो रिप्लेस दिस I, okay, you can also replace this I by V by R, since I is nothing but V by R from the Ohm's law, I and V relationship. So power is going to be what, V times V by R, right? So power is also defined as V square R, right? V square by R and I square by I square R, right? So these are the two expressions that you have to remember for power, right? Power, okay. So power, if you get power, you can find the energy simply, right? So power is nothing but this, right? So remember always, if current is, suppose we are talking about instantaneous power, so PT is going to be I square T okay, I square T times R, or you can say that V square T times R. So these are the expressions that you have to remember, okay, for resistance. Now, so always remember, a resistor always dissipate power, right? Okay, a resistor always dissipate power. Okay, this concept I used to teach in 2011, when I was in third, I think, when I was in, you can say fourth semester or something. So I used to teach these concepts to my friends, right? So resistor always dissipate power. If you talk about in terms of absorbing or delivering powers, you can say resistor absorbs. Okay, it does not deliver the power. Okay, it absorbs the power, right? It dissipates the power always. Always is the important word here, right? So please remember this. In the form of heat, you will be getting over there, right? Okay. So if I talk about energy delivered to the resistance, okay, so energy will be delivered to the resistor in certain interval that you have to remember, right? So interval will be given, so energy can be computed, right? So energy delivered to a register. Okay, so in the question they will specify the interval, right? So it is nothing but what? E will be from T1 to T2, I square T times R dt. Okay, just you put power, or you can also find this as T1 to T2 V square T by R dt. Right? So simply you have to integrate PT, right? I mean the power with respect to time. Okay, and this should be greater than 0. This should be greater than 0. Energy should be always greater than 0 here. Okay. So a resistor always absorbs energy, cannot deliver net energy, right? It always absorbs energy. Okay, remember this. Okay, it cannot deliver net energy, right? It cannot deliver net energy. It always what? It always absorbs energy. So this is the property of passive element, right? The passive element is there, right? Okay, so it will absorb the energy, you can say. Okay, this is important, right? Sometimes you will see the capacitors and all, they will store energy, right? Okay, and at the same time they might work as a source also in future. I will show you, right? So this is all about power energy. So if I suppose IV characteristic is given, okay, there are many questions will be asked to you, like if suppose diode is what? Diode is a passive element or an active element, right? So if you know the IV characteristic of any element, right, so you can basically tell that whether if something is delivering power, if something is absorbing power, right? Okay, so if something is absorbing power, so you can say that that is going to be the passive element. Okay, something absorbs the power, right? Absorb power. And if power is delivering, right, some element is there which is delivering power, right, or exciting the circuit. Okay, so that is going to be an active element, right? So based on the IV characteristic, you can talk about that. So let me draw here the IV characteristic. Okay, so IV characteristic is what? For any element, right? You can always imagine for element, any element, I versus D, right? So suppose we have got the characteristic like this. If I talk about the resistance, so the characteristic is going to be like this. Okay, this is the resistance. Okay, I think this is clear. This is the IV characteristic for resistance, so this will absorb power, right? Absorb power. Okay, it passes through origin, you can say. And if I talk about diode, diode IV characteristic look like this. It passes through origin only. Okay, but it is highly non-linear. Right? You see, exponential in nature, right? And this is non-linear kind of thing. Yeah, like this. Okay, you see here, it is also it belongs to, you can say, this is the first quadrant, this is the second quadrant, and this is the third quadrant, and this is the fourth quadrant, right? So if your characteristic belongs to, these curves are lying on first quadrant and the third quadrant, you have to make sure that this will absorb power only. Absorb power. So your diode is nothing but what? Your diode is the passive element, you can say, not the active element. Okay, don't consider diode as a passive element, sorry, active element, right? Why diode is not the active element? Many people get confused, right? Okay. Many people get confused that diode is a active element, right? So it does not deliver power. Diode does not deliver power. It might absorb power, right? So you see here the characteristic, this curve, IV curve, it belongs to first quadrant and the third quadrant. So you can make sure that the device, the diode is going to be what? Absorb, I mean the passive element. Okay, and suppose the situation is like this. Suppose The IV curve is like this. Okay, so this curve belongs to the second quadrant and the fourth quadrant, right? Second quadrant and the fourth quadrant. Here the resistance is basically negative. Okay, in this case the resistance is negative, right? Here what is the situation? Resistance is positive. Okay, and your power is also positive. Okay, it means Vi is positive, greater than 0, right? In this case you can say that here V is less than 0, I is less than 0, so product of V is greater than 0, right? The product is positive, right? So absorbing power, remember in second quadrant and the fourth quadrant, here the power will be delivers power. Okay, delivers power. Please remember this. Okay, so you can conclude here that first and the third quadrant means absorb power. So any element which belongs to whose IV characteristic belongs to first and the third quadrant will be considered as passive, okay, element. आज से याद रखना, because many people have lot of confusion, right? In some of the exam they might ask, okay, or in some of the interviews. So remember, first and third, if your IV characteristic belongs to first and third, right, quadrant, so here what will happen, the power is what? Absorb power. That element will absorb power, means you can say this is the passive element, right? Okay, and if you can say it's second and the fourth quadrant, if second and fourth quadrant, so here what will happen, the power is delivered, right? You can say delivers power. The element is going to be delivered power. So this kind of element is basically active. So I need not to specify here what is active element, what is passive element. So looking at this IV characteristic, you guys can always talk about what? You guys can always talk about which one is active and which one is passive. Okay? Which one is active and which one is passive. Please remember this. So I think this is clear. Okay. So you have to remember these points. These points are very, very important to keep in mind, right? So from this IV characteristic, you can talk about. Let us take some example here, right? Let us try to compute some power, or you can say energy. Suppose you have got 1 volt, 1 ampere, right? 1 volt voltage and 1 ampere current. So what will be the power? Power will be in watt, 1 watt. How do we define 1 watt? 1 watt is nothing but 1 volt times 1 ampere. And this is called 1 watt of power. 1 watt of power. And we basically talk about energy in joule. Okay, energy in joule, right? So 1 watt of power, if you have got, right, 1 watt of power you can say. So 1 watt of power can be written as what? 1 watt of power, right? It is nothing but 1 joule by 1 second, right? 1 joule by 1 second. 1 watt of T. This is another way of defining this 1 watt, right? So 1 joule by 1 second. So you can say 1 joule is going to be 1 watt into 1 second, right? Okay, so 1 joule is going to be watt into second, right? This is very important. Okay. Suppose we have got a resistance here, some resistance is there. Okay, and we have got 1 kilo ohm resistance, and the current is flowing through this resistance is nothing but what? Suppose the voltage across this is 2 volts. So current you can quickly find out from the Ohm's law. Ohm's law is one of the very good law that gives you the defining relationship between voltage and current through any passive element. Okay, so it will be 2 by 1 kilo ohm, which is 2 milliampere. Okay, which is 2 milliampere, right? The power is going to be what? The power will be what? The product of voltage and current, right? So this is the current and this is the voltage. So you can say that 2 into 2 milliampere. Okay? So it is going to be 4 milliwatt. 4 milliwatt is going to be the power, right? And I think this is clear for you, right? So 4 milliwatt is going to be the power. This is how we can find out, So V into I you can use, or you can use V square into R, V square by R also you can use, or I square R you can use, right? So whatever formula you want to use, you will be getting the same answer same answer, right? So depending upon the given information, you can decide what formula that you're going to use, right? Okay, so here you can also use I square R, V square by R, okay, you will get. But I think simply using product, voltage and current gives you the quick answer, right? Instead of solving I square times R, then V square by R. So you have to do, all sort of things, right? Here directly you can use V times I if you know the voltage and current to any element. Fine. And this was quick answer. Okay, so this is very important. Now the question is, suppose 2 volt is applied to the resistor for 500 seconds. Okay, suppose 2 volt is applied. Suppose there is a resistor. Okay, this is a resistor. Okay, and the 2 volt is being applied across this for, you can say, for 500 seconds. Right? For 500 seconds. Okay, so what will be the energy here? That you have to decide, right? So since you know the power, energy is gonna get dissipated across the resistor. Okay, so so 500, for 500 seconds you are going to apply 2 volt, right, across the resistor. So 4 volt you got 4 milliwatt into 500. So the energy is going to be what? 2000 millijoule, which is nothing but 2 joule. Okay, so this is how you can find out the energy, right? So simply what you need to calculate power first, then you can multiply, or you can just simply integrate. Since the power is here, the power is nothing but what? Here the power is constant, 4 millivolts, so simply multiply by the time interval. Okay. So calculation of power and energy in case of resistor is straightforward concept. Okay, you don't need to apply very tough algebra or something. But now let us talk about power and energy in the capacitor. Okay, the power and energy in the capacitor, right? So that is very important. Power and energy, okay, in the capacitor. Though this is very important, capacitor. So finding energy in the capacitor, okay, like RC circuit is given, suppose. So they will always ask power energy in you can say at a steady state or something. So you can directly find the energy and all, right? So one of the student was there, right? He is still here, right? He told me the technique, right? So I was familiar with that technique prior, but what happens? Suppose what we always do is we look at some solution at different publications, right? And we follow those solutions. That is one of the bad way of learning concepts, remember. So if you want to learn the concept, try to solve the question by your own, right? Don't follow those instructions which are given in any publication, right? You can follow the instructions which are given in the books, right? Reference books I'm talking about. But don't follow those restrictions where the solution is specified and your brain is not working. Okay, so in that process you will not get self-realization of the learning, right? So you need to understand self, like you have to realize, okay, that yeah, you are able to solve the question before the exam. ठीक है, तो पहले से आपको realize करना जरूरी है. Let us take a capacitor here. So my capacitor looks like this. Okay, and the current flowing through this capacitor is IT, and the voltage across this is nothing but VT. IT and VT. IT and VT. You can say this is nothing but a capacitor. So if I talk about defining relationship here, okay, so suppose this is I and this is V across the capacitor, this is C. So I equal to what? C dV by dt. C dV by dt, right? C dV by dt. Okay. Now this current, the power will be what? The power is going to be equal to same. The power is going to be P into IT. So what is this current? This current is nothing but this C dVc by dt. So we can plug here C Vt dVt by dt. So the definition of power is going to be same only, the product of voltage and current, right? But now as long as the the relationship between voltage and current in case of capacitor is this, where the derivatives are involved, right? dV by dt, the rates are there, right? Because your capacitor is kind of a memory element. It stores charges. Okay, it will store energy also. You will come to know, right? So and your capacitor cannot charge suddenly, right? It takes time to charge the capacitor. Okay, as long as the current is flowing through the capacitor. Okay, so now we need to discuss when capacitor is going to absorb, when capacitor is going to deliver, right? All these things we are going to see. Okay, this is very important to understand. So suppose it depends upon the voltage characteristic. Suppose we have got a voltage curve, right? You can say this is voltage versus time, and the voltage curve looks like this. This is a voltage curve. Okay, this is a voltage curve, and you have to understand this. This is very basic concept that you have to learn. Suppose here, what is there? Here voltage is greater than 0 means your rate of change of voltage. You can say dV by dt is also greater than 0, right? That you can say. So in this case, what will happen? Your power is going to be positive, right? Power will be positive. So you can say absorbs power, right? dV by dt is positive means what? dV by dt means this initial rate, you see, increase. The slope is positive here, it means dV by dt is positive. If the slope is negative, right? See, here in this case, you see here the voltage is positive, but the slope in case of this, this slope is nothing but dV by dt, which is less than 0, right? So differentiation or derivative always indicates slope. That is very important to remember. So you see here dV by dt is less than 0, right? dV by dt is going to be less than 0. So in this region, power is going to delivers. Okay, remember, because the product of current and a voltage, like C times Vt times dV by dt, right? In case of capacitor, we need to compute dV by dt also, right? Suppose you have got voltage across the capacitor, okay, then what you have to do, you have to differentiate that. Okay, you have to know the initial rate, right? dV by dt, or you have to differentiate that and then take the product, right? And then multiply with C. Now come to this region of the voltage curve. So here the voltage is negative and your dV by dt is also negative. So you can say in this region, for this region, the power is gonna absorb, right? And if you come to this point, right, so here the voltage is less than 0, but dV by dt is greater than 0, again deliver. Okay, so sometimes your capacitor is going to absorb the power, sometimes it is going to deliver the power as well. That depends, right? So it is very great, you can say very amazing characteristic, right? Okay, so depending upon the voltage, right, depending upon the voltage curve which is given in the question, right, so you can decide. So I have shown you in general understanding. Okay, you should never get confused, right? But the defining relationships are same, whatever relationship we have seen. Now if I talk about energy delivered to the capacitor, right, okay, so there will be some interval, okay, up to which the energy is going to get delivered. You can say from 0 to t1, okay, or something, right? So energy delivered to the capacitor is very, very important concept, right? Energy delivered to the capacitor. Okay, so energy delivered to the capacitor means what? It will be nothing but pt dt. Okay, you have to just integrate it, right? You have to integrate. Okay, so you can integrate from, suppose you have got a curve. Okay, let me show you the curve, voltage curve. Suppose the voltage is there V versus time t, right? V versus time t, and your voltage is like this. Okay, so initially voltage is 0 here, so the power energy is gonna be 0, right? This is 0 here. Okay, now this is a point, right? You can say that this is a point. Okay, we can take here, you can say this is t1, right? If I integrate this from 0 to t1, right, for 0 t1, where the energy is gonna get absorbed, right? In this case, the energy will be absorbed, okay, because the dv, see, voltage is positive as well as dv by dt is positive, the slope is positive. So 0 to t1, if I integrate, you can say v times I dt, and then you can say that c is constant, so 0 to t v, and then dv by dt, okay, times dt, right? Okay, I think this is clear. Now what you can do here is, you can say that you can write this as this is very important to understand. Now you have to manipulate here something, okay? So if you want to manipulate, then what you will do here is, it is very, very important to remember. So if initial voltage is 0, right? So initial voltage, initial that the energy absorbed, right? Like whenever you will try to find, so initial energy is going to be 0 also, right? That is very important. Okay, so whatever energy will compute here is going to be the steady state energy, you can say, right? 0 to t1 vt. Okay, now how can we manipulate this? Okay, so we can manipulate here. Okay, this is important. So you remember this can be manipulated. Okay, so how we can get this expression? How we can get this expression? Suppose you have got simple dv by, suppose d by dt, v square if you are differentiating. So it is nothing but 2v dv by dt, right? You can say that v dv by dt is going to be equal to what? V dv by dt is going to be equal to 1 by, you can say 1 by 2 dv square by dt. You can write like this. Okay, so you just put this, okay, here. C by 2, 1 by 2 will be out, 0 to t 1, 0 to t1, and then d by dt, okay, d by dt, and this is nothing but v square dt, right? I think this is clear for you, right? Now what will happen here is that, what will happen, you can say that now it is independent of t, dt you can cancel also, right? Okay, so you will get v square only, right? You will get v square because integration will cancel the differentiation, right? Integration is going to cancel the effect of differentiation. You will get here what? 1 by 2 c dv square, 1 by 2 c dv square, and here t equal to 0 and t equal to, you can say at t equal to t1, the voltage is vc. At t equal to 0, the voltage is 0 only, right? Okay, so this is very important. So you can say that it is going to be 1 by 2 cvc square, simple. Okay, so this is going to be a final you can say at vc at t1, right? This is the maximum energy that you are going to obtain, right? 1 by 2 at vc, 1 by 2 c dvc square. This is the energy will be stored by the capacitor, right? Understood. So this is how we compute it. So half cv square is one of the defining relationship, okay, for the energy. Please remember that. Okay, so if I ask you, suppose we have got a capacitor, let me take one quick example. Okay, certainly one question you can expect, right? Certainly one question. So suppose we have got a capacitor. If this is a capacitor, right? This is a capacitor, and the current flowing through this capacitor, you can say, is I, and the both capacitor C is there, and some value is there. You can say 10 nanofarad. The 10 nanofarad is the value of the capacitance, or a size of the capacitance, and this is the voltage V. Now you know that you can find here, right? So I suppose they have given the voltage curve, right? They have also given here the voltage curve of this kind. ये voltage curve दिया हुआ है. So this is voltage applied across this capacitor, right? Now what they are asking is, they are asking the energy stored, right? What they are asking? They are asking the energy stored, okay? And this curve, it is changing. It's like it is initial, you can say voltage here, right? It is voltage is changing like this, then it is constant after some time. You can say 10 microseconds. So no. So if someone is going to ask you what will be the energy, you can say, in this duration after 10 microsecond, right? So voltage is constant, right, across the capacitor. If the voltage is constant across the capacitor, what is the meaning of that? dV by dt is going to be 0, right? If the voltage is constant across the capacitor, so you reach the steady state, you can say, right? Okay, so voltage is going to be, I mean, okay, that is very important. So t greater than, t after 10 microseconds. Okay, so this voltage is going to be constant across the capacitor, right? So dV by dt is going to be the rate of charge is going to be 0, right? dV by dt. Okay, so current will be 0 then. If the current is 0, no, okay, that is very important to remember. So yeah. So if I try to draw the curve also for current which will flow through the capacitor, right? So initially it is going to be 0 here, but for 10 microsecond it will be like this. Okay. How can you find this current? Current can be found out using the relation C dV by dt. So I equal to C dV by dt. C is nothing but 10 nanofarad, and dV by dt you can find out from here, okay, from this curve. So there is a ramp, you can say. There is a ramp. So if you differentiate the slope, already there is a slope, right? And if you differentiate the slope, right, if you are finding the slope only, right, so you can directly write this is nothing but this maximum voltage is given as in this question 5 volt. So it is one of the beautiful question, right, you can say. So 5 volt upon 10 microsecond, right? So you can solve this. It will give you 5 milliampere current, right? So in 10 microsecond duration, when the voltage is 5 volt here, as it is starting from 0 onwards, so the current is going to be 5 milliampere, right? So I think this is clear, right? So now what is the energy stored? Energy stored is going to be, you can find energy stored, right? So energy will be stored in this duration only from 0 to 10 microsecond. After that, it will be 0. Energy stored. Okay, so don't worry about this, okay? You have to just find the energy for this duration, right? So energy stored is going to be 1 by 2 CVC square, right? Half CV square, you can say, okay? At the rate 10 microsecond. Okay, so this is half to 10 into 10 minus 9 nano, okay, farad, and then it is nothing but 25. So it will be 125 nanojoule. And this is the energy stored, right? This is going to be a energy stored, right? So, and the power, what will be the power here? This is going to be energy stored, right? 125 nanojoule. Now, if someone is going to ask what is the power, the power is nothing but what? Power is nothing but just take capacitance, right? That is 10 nanofarad, and then multiply with the voltage, right? That is nothing but 5 volt here, okay? And then you dV by dt multiply, right? So you can get the power. Power will be 25 milliwatt, right? Okay, so this is very, very important to remember. Okay, so I think this is clear how to find that. So you will be given one voltage curve, you will be given, or they might give you current curve also, and they might ask you power and energy. You guys can find out this. So major complication comes into picture is when people talk about energy or power in case of capacitor or inductor, right? So many people get confused, but you don't have to confuse. Now let us talk about energy and power in an inductor. That is important. Energy and power in an inductor. Energy and power in an inductor, right? So suppose we have got here the inductor here, right? Inductor, okay, and inductor has got this L, and there is a current I flowing, and this is voltage V, okay. So what is the defining relationship? If I ask you, V equal to L di by dt. The moment you see the inductor, you should be able to understand the relationship between voltage and current, right? Voltage and current. So it should not be like that, oh, you don't know V equal to L di by dt, right? During the examination, you don't have to remember these, okay? Just like, you can learn from the semi-final what I say, right? They don't recall what they have done in the past. They just do at the present, right? At that present moment, right? So अब जैसे you got to see the inductor means defining relationship v equal to L di by dt. ऐसा नहीं है कि सर भूल गया था, पता ही नहीं है. कुछ लोग ये भी नहीं जानते हैं एल डी आई बाई डी टी क्या है, राइट, कैसे आया. ठीक है, तो आपको तो मैंने सब बता दिया है, तो रिमेंबर इट. तो डी वी इक्वल टू एल डी आई बाई डी टी. क्यों क्यों मैं बता रहा हूँ ऐसा, क्योंकि this di by dt is going to decide whether power will be absorbed or delivered, you know. In case of inductor, there can be power absorbing, there can be power delivering depending upon di by dt, right? So this is very important to remember, right? So the power is basically vtit, right? Power is nothing but vtit. And okay, so you can write here L in place of V, L it dit by dt, dit by dt. Okay, now let us take here, suppose I is greater than 0, I is greater than 0. Okay, and the slope is increasing, you can say, right? You can say di by dt is greater than 0. See, di by dt is greater than 0 means slope is increasing, right? Your current is increasing, you can say. Okay, and increasing. If current is increasing, so what will happen? The power is gonna get absorbed, right? So absorbs power. Absorbs power. Okay, please remember this. This is important. And if current is greater than 0 here, if current is greater than 0 and decreasing, so mathematically how we can say that, the suppose any function is given and it is decreasing function, it means the derivative, you know, the slope is going to be what? The slope will be greater than, less than 0. Okay, and it will deliver the power. So depending on this guy, this is very important to decide. Okay, when and what situation, right? The power is gonna get delivered or stored, right? So basically we talk about power stored, right? I mean energy stored in the inductor, right? In the form of electromagnetic, right? We know that in the form of magnetic, okay? Magnetic energy is there, right? Half Li square, okay? Half Li square. So we have to only focus on that interval where the energy is absorbed or is stored, right? We don't talk about energy where the energy is gonna get delivered or something, right? आप लोग याद रखना. So delivery is different. So here I is less than 0, suppose. So one more situation, I less than 0 and you can say increasing. So product will be negative only, right? तो यहाँ पर क्या होगा? Deliver. And if I is less than 0 and decreasing, you can say, okay, means di by dt, so it will absorb power. So all these cases you have to remember. I think these cases are not taught anywhere, तो आपको ये याद रखना है. In case of inductor and all. So let us compute the energy absorbed by the inductor over a time interval. So always they will ask question, what will be the energy absorbed by the inductor over a time interval. Okay, so whenever they talk about energy, they will always talk about some sort of a time interval, right? So suppose we have got one inductor here, right? And the current is flowing through this inductor like this, I, and this current has got some sort of a curve. Okay, so in the question they will mention this curve, I versus, you can say, t. Okay, so initially your current is starting like this and it is increasing, right? You can say at this time t1 there is a current, you can say IL, the inductor current IL. Okay, so this is a curve associated with this. Okay, now if I ask you that over a time interval, right, over a time interval 0 to t1, you can say, so we are trying to find energy absorbed, right? Energy absorbed by the inductor, okay, inductor over a time interval. So whenever you read the question, right, whenever you read the question, everything should be clear. I mean, everything should be crystal clear. Acha, what they are asking and what you have to do. I'm talking about final match, you can say, final exam day. वहां पर आपको प्रैक्टिस नहीं करना है, ठीक है? नहीं तो 40 नंबर ही आएगा, 30-40 इनफैक्ट डिस्क्वालीफाई हो जाता है गेट, ठीक है? क्योंकि उस 3 आवर्स में अगर आप परफॉर्म नहीं कर पाते हो, नो मैटर फ्रॉम विच कॉलेज यू बिलोंग टू, no matter from which city you belong to, whether you are staying in Bangalore, Delhi, Mumbai, anywhere, right? No matter you belong from village, कहीं से भी belong करो, ठीक है? During that 3 hours, if you're not going to perform well, you're not going to qualify the gate examination. और क्वालिफाई करना इज नॉट अ बिग थिंग, राइट? मतलब क्वालिफाई करके कोई बेनिफिट नहीं है इंडिया में. इनफैक्ट 30-40 मार्क्स करके भी कोई बेनिफिट नहीं होता, राइट? So until and unless you get into some top NITs, top IITs or ISC, right, and you get some good branches like VLSI or AI, data sciences, right, computer sciences, okay, so then your career is there, right? Otherwise वही प्रॉब्लम है, क्योंकि इंडिया में आपको पता ही है कि ऑलरेडी देयर इज अ जॉब्स बहुत सारी हैं, बट द स्किल्स आर वेरी लेस, राइट? सो स्किल्स आपको इंप्रूव करना है वाया गेटिंग इनटू IITs, राइट? तो प्लेसमेंट अच्छा होगा. आफ्टर कोविड दिस हैज गॉट ठीक है, तो आपको स्पेसिफिक डोमेन में अपने आप को स्किल कर लेना है, ठीक है? तो नाउ, so if they are asking, so what is this? This is nothing but PDT, right? Simply power times PDT. So energy is going to be equal to what? VT times IT dt. Now plug all these values. So L is, you can take L IT DIT dt. So we got this I times di by dt. So you can say that. You can also write like this, no problem. Okay, so if you want to find the relation, so I di by dt. So if you got this now, so this is nothing, you can write this as 1 by 2 L by 2, sorry, L by 2, okay, 0 to t1, okay, 0 to t1 dy by dt I square dt. Simple manipulation you have to do. So it will give you nothing but what? It is going to give you half Li square. What it gives you? Half Li square, okay? Half Li square, you can simply. So I think this is clear for all, right? So this is nothing but what? Let me write here. So 1 L by 2, 0 to t1 d square it by dt. So you can write this as 1 by 2 L it and t equal to 0 में 0 current, okay, and t equal to t1 में how much current? IL. You can say that 1 by 2 some constant current is there, right? So the fixed current, at a steady state, this is the energy I'm telling you at a steady state event, because the maximum current this can flow, right? IL. So half Li square Li square, you can say, right? So energy stored in an inductor carrying a current IL, right? आप इसको क्या बोलोगे? This is nothing but energy stored in an inductor, okay, carrying a current IL, okay, carrying a current IL, okay, which is half Li square, and this can only absorb energy, right? This can only absorb energy, okay, absorb energy, right? So it is a passive element, passive element, passive element, understand? Okay, so depending upon the IV curve, right? So if sometimes what will happen over there, depending upon IV curve, that you can decide, right? So if it is a passive element, right? So yeah, certainly it should absorb power. That will be half Li square, a half Li square. So this is all about energy, and you can talk about, right? So let us take one example, a very quick example we can take. Suppose we have got inductor and the current is there, I. There are some values we can say 1 millihenry is the inductor value, and the current I is there, okay. Uh, so we can find the voltage across this also. So depending upon the I, okay, so they have given I here, like they have given I like this, I versus T. So okay, for 100 microsecond, it is like this, 100 microsecond. There is a negative value, you can say 10 milliampere. Okay, 10 milliampere is flowing, right? I think this is clear. Okay. Now, if this is 10 milliampere, right? Okay, 10 milliampere. So between 0 to 100 microseconds, if you try to find di by dt, right? Di by dt, so you will get what? You will get the negative. There is a negative slope, right? Certainly there is a negative slope. Okay, minus 10 milliampere. So you will get minus 0.1 volt, right? And after 100 microsecond, 0, right? Okay, so it is very simple to compute, right? The voltage. So how can you find the voltage, right? Voltage, to find voltage using this I current characteristic or a current curve, you can use the simple definition, right? V equal to L di by dt. बहुत सारे लोग यही नहीं कंप्यूट कर पाते हैं. तो this is 1 मिली हेनरी and di by dt कैसे कंप्यूट करोगे? Di by dt is nothing but this. So differentiate this. It is nothing but minus 10 milliampere. Okay, minus 10 milliampere upon 100 microsecond. See, di by dt is nothing but a slope of this current curve, right? Slope. Derivative stands for slope, okay, in the mathematics, right? तो आपका मैथ सही होना चाहिए. तो you will get here minus 0.1 volt. You can plot here now. So it will be like, initially it will be 0 only, but now it is like this. After that it will be 0 again. It is 0.1 volt, right? Now you want to find what? You want to find the energy at t equal to 100 microseconds. That will be the steady state energy, right? At t equal to 100 microseconds. So half Li square. So you should know the current at 100 microseconds. So into 1 millihenry into I. I is given as minus 10 milliampere, matlab 100 into 10 raised to the minus 6. You will get here as 50 nanojoule around, right? You can compute it, right? So this is going to be a. Now you can also find the power. Power is going to be what? Power will be just no. Power is going to be positive only, because the product of I into V is going to give you the power positive, right? So power is positive, matlab it, it is absorbing power, right? So okay. So you guys can draw it, okay? What will the power here, right? Since you know the voltage as well as the current, right? So just multiply here, okay, and you will get the power. Okay, so how to find the power? Power is nothing but L and times voltage. Okay, sorry, L into current into, you can say, di by dt simply. You guys can find the power. Fine. So I think this is clear. This is clear, right? So power and the energy is okay, right? Now we'll talk about energy and power in the voltage source. Okay, the power and energy in the voltage source. So suppose we have got a voltage source here, you can say V naught, and the current is flowing, you can say I naught. V naught and I naught. V naught and I naught. Understood. So V is going to be equal to V naught. V is going to be equal to V naught, and the current is I. Okay. Now, if I want to find the power and energy in case of voltage source, so V equal to I, P is going to be what? Again, defining relationship will be same, right? Okay. So P equal to VI. Okay. So remember, if this voltage is positive, right? I mean, if this, you can say that if this power is going to be positive, suppose current is entering, okay, to the voltage source, in the voltage source from plus terminal, right? So power is going to get absorbed by the voltage source, right? Okay, understood. So this power is deliver to the voltage source means what? Absorbed by the voltage source. Okay, this power delivered to the voltage source means what? The power is absorbed by voltage source. Please remember this. Okay, this is very important. So if you look at the IV characteristic, always try to decide the IV, always try to go for IV characteristic. Suppose this is voltage and this is current, I versus V. So you draw here, this is the IV characteristic of voltage source, like ideal voltage source. So voltage source, what ideal voltage source, or you can say independent voltage source, says that what it says, okay, I'm not going to change my terminal voltage, whatever current flows. Okay? In this case, you see here, if you are in first quadrant, so here voltage is 0, current is, sorry, greater than 0. Voltage is positive, current is positive, you can see here. So here what will happen? The power will absorb. It means it is just like a passive kind of thing, right? Okay. When current flows, if you follow the passive sign convention, if current flows through the plus terminal, means the voltage is positive as well as the current is positive. So that will absorb power. So I will always suggest that try to remember using this IV relation, IV characteristic. Okay, it is a smarter way of understanding. So voltage is 0 here, but current is less than 0. So here the power will deliver. And one more thing that you can notice, you are in the fourth quadrant. If something is in the fourth quadrant, so it is going to deliver the power, right? Here the device will become active, right? Okay. So the voltage source can energize the network or a circuit, right? Okay. That you have to remember. Okay, and it can also absorb. Okay, so if current is flowing through the positive terminal of the voltage source, right, and look at the IV characteristic always, right? And one general understanding I have given you, if your IV curve belongs to first and the third quadrant, the power is going to get absorbed, right? And if you can say that the IV curve is going to lie in the second and the fourth quadrant, it is going to deliver it, right? So depending upon that, you can decide whether it is active device or a passive. Okay, that depends upon you. Okay, so this is very, very important to remember. Fine. So this is all about, guys, the power as well as the energy, right? Okay, power as well as the energy. So it is going to be an active element, right? It is going to be an active element. So this is the power. So how can you find the energy? Energy is nothing but P dt, simple. Okay, energy is going to be P dt. Simple, you have to integrate it, okay, over some interval. Chalo. So let us take one very simple example, and then we can talk about everything here, right? So I'm just going to take one simple example. Suppose we have got a resistor here, okay, and you are applying some sort of a voltage source, you can say. It this is a voltage source of, you can say, 5 volt. Okay, and single example will help you to understand everything, right? Suppose this is V1, right, and this is R, which is 1 kilo ohm. We can talk about whether power will get delivered or absorbed, right? Here, if you follow the passive sign convention says that the current is going to flow through this R by like this IR. But if you follow the passive sign convention, so in this case current is going to flow how? Through this plus only, right? So you can say that the current is flowing I1, okay, through voltage source. So here you can say the VR is nothing but what? V1, right? Voltage across this is nothing but VR, right? So VR is going to be equal to V1. But if you notice here, the IR is opposite to this I1, right? Because it should always satisfy the KCL, right? As long as elements are connected in series, right? Okay. So बहुत सारे लोगों को doubt होता है when power is going to get delivered, when power is going to get absorbed. So you have to always remember, okay, the passive sign convention. If you are defining current, like if you're showing current directions using passive sign convention, you see I have shown here, right? So this is going to be the annoying condition that you might find, right? So V and I passive sign convention for the voltage source, V and IR passive sign convention for resistor, right? So power will be absorbed by the resistor, that is going to be VRIR, and power will be absorbed by the voltage source, that is VI into I. You see what you are going to get here. What? So you can find the IR from here. What is the value of IR then? So IR is nothing but this voltage 5 by 1K, which is 5 milliampere, and you can say that I1 is going to be minus 5 milliampere. So as per the passive sign convention, see, if in the question they have specified the direction, remember, if in the question they have specified the direction, don't change the direction of the current, right? Suppose they are asking find out the power delivered to this source, right? And the current direction is from negative to positive, right? Current is entering from negative to positive, so your power is going to be positive only at that point of time, right? But suppose they haven't specified anything and they are asking find out the power absorbed, right? Okay, so in that case you have to choose passive sign convention, right? So passive sign convention से क्या हो जाएगा? Power absorbed by voltage source will be what? VI into I, V1 into I1. So what is this V1? V1 is nothing but 5 and I1 is nothing but minus 5 milliampere, which is minus 25 milliwatt. So if someone is going to ask you what is going to be the power absorbed is nothing but what? Minus 25 milliwatt. And if you want to say that power has got delivered by the source, voltage source, so 25 milliwatt, right? So here the negative power. I think this is clear. Why this negative sign is coming? Because of this current, okay? Because of my passive sign convention, right? Okay. And now remember, if power absorbed by resistor, I'm finding, see, power absorbed by resistor or resistance. So what will be that? V into I only, right? So VR into IR, 5 into 5 milliampere, which is 25 milliwatt. It is positive, right? So I hope this makes sense to all, right? So if someone is going to ask you how much power got delivered by the voltage source, so you have to say 25 milliwatt, right? Okay. And you can also think about conservation of energy, right? Okay, conservation of energy, right? How much power is going to get delivered, how much power is going to get dissipated, both should be same. Okay, I mean, okay, the total, I hope this makes sense, right? So the power got absorbed by the resistor is 25 millivolts. Power, the voltage source delivers the power 25 millivolts. That is very, very important to remember. So according to passive sign convention, you guys can define the current, I mean current direction, okay, and so on and so forth, and then you can decide it. Okay. So I think this is clear, right? So how we claim that the voltage source is absorbing power or delivering power. Okay, this is very, very important to remember. Understood? So suppose we have got a black box and the black box containing only resistor. Well, this is a black box and this black box contains only resistor, and there is a voltage source, you can say, connected to this black box. This black box network it is, okay, and there is a voltage source, okay, connected to this resist, okay, this entire network, and this network is, you can say, consist of only resistors, right? So single source is there, so it will be delivering power, remember, okay? If there is a single source, you can say this is a single source, okay? So it will deliver power, okay, deliver power. It will deliver power, then only this resistor will dissipate power, right? That in this manner also you can think about it, right? So current will be flowing through the we will, you know, always we will consider the current like this. Current is flowing through this, okay, and the current is returning like this, okay, understood? So if in the exam, okay, if entire circuit is a network, I mean entire network or circuit is basically a resistor, okay, all the elements are resistor, and only one source is, you know, exciting entire network, right? Okay, understood? So this is a black box consisting of only passive element, you can say resistor. So this guy, the single source, is going to deliver power always, that you have to remember, okay? But suppose you have got a next situation. Suppose this is a black box containing only resistor, you can say, okay? But there are multiple sources. You can say one source is this V1, and one source is this, you can say V2, and one source is here, right? You can say there are multiple sources, not single source, okay? Understood? So some source could be absorbing power, that is also very important, right? Now you can't decide, okay, because only delivery will be there, okay? Some source will be or could be absorbing power, right? So you can say that some source would be absorbing power, okay? So if in the question, okay, single source is only connected, single source, and that single source is exciting the network, so you have to consider that source is going to deliver only the power, okay? It will deliver the power for entire network, okay, so that they can dissipate, they can store whatever they want to do, right? But if there are many, you can say many sources are connected in a network, and that black box is nothing but what, made up of only resistors. So, you know, situation will come to picture, okay, that the power can be absorbing also. So remember, they might ask questions, right? What will be the power absorbed by that voltage source or something? So you have to find out, right? Deliver will be positive, but absorb will be negative, depending upon the current direction. If current is flowing through the, okay, that is very, very important. So let us take one very easy question, right? Okay, like whatever I said, suppose we have got a resistor, a single resistor is connected here. I mean, there can be many resistors connected in different elementary connections like parallel combination. So we have just find out R equivalent, you can say, and there are many sources, you know. So we can connect voltage source. How can we connect voltage source? Okay, we can't connect different voltage source in parallel, right? We can connect voltage sources in series, right? Different voltage sources in series. So we can say that here the voltage is nothing but 3 volt, right? And here the voltage is nothing but 8 volt, right? Okay, so I think this is clear. Now you see, this is VR, right? And this resistor has got the value 1K. And the voltage across, this is V1, this is V2. You can say V1 and V2. According to passive sign convention, you guys can define, right? According to passive sign convention, the current flowing through this is IR, and the current flowing through this is nothing but I. I'm just taking this, okay? Like you can say that the current is flowing here through this is nothing but I1, through this is also I1 only, because they are connected in series, right? Simply you can say I2 also, if you want to be very specific, I2, but the current is going to be same only, right? I2, because Okay, let me take some different. Suppose you say this is nothing but V1, so current is I1, and this is nothing but V2, so current is I2. Okay, current is I2. Right? Now, according to passive sign convention, I have considered this. Okay, I have considered this. What is the current flowing through this resistance? Right now, you can say that V1 is nothing but 8 volt. Right, V1 is nothing but 8 volt. V2 is nothing but minus 3 volt. And VR is nothing but VR, total voltage across this, right? So it is 8 minus 3, that is 5 volt. The current will be what? IR is going to be 5 upon 1 kilo, that is 5 milliampere. 5 milliampere. The product will be what? PR is going to be 25 milliwatt positive. Okay, you are getting positive means power is what? Power is going to absorb here, right? If the current is positive means power is going to get absorbed, right? And in this situation, what will happen? I2, you can say I2 is going to be what? Opposite of this. Opposite of this current. I2 is nothing but what? Opposite of this IR. So you can say that it is going to be minus 5 milliampere, which is going to be 15 milliwatt. Again, it is going to absorb only because it is positive, right? It is positive. Okay. So the power is going to get absorbed, right? Okay. Because voltage is negative as well as current is negative, so it belongs to third quadrant, you can say, right? And then if you talk about V1 and I1, this V1, so V1 is 8 and I1 is negative here, right? You can say that I1 is going to be minus 5 milliampere, so it is minus 40 milliwatt. It is negative, right? So you can say that this is delivering power. So this V1 is delivering power here. Okay, so what you can talk about, guys, always remember, if there are many voltage sources connected in the network, so they can deliver power, they can absorb power. So in the exam, if they will ask anything, don't get confused, right? अगर सिंगल सोर्स कनेक्टेड है तो हमेशा क्या करता है? डिलीवर करता है पावर, अगर प्लस टू माइनस प्रॉपर साइन कन्वेंशन अगर दिया है तो ठीक है. You guys can always understand. Okay, many questions are asked, right? So आप समझ सकते हो क्या होगा. ठीक है. अगर if I talk about power energy in the current element, current source, you can say, right? This was idea behind voltage source. Now we need to talk about current source also. Okay, and then we will wind up the session. Then we will start the circuit analysis. That will be, we'll talk about nodal and mesh analysis. So I will give you the smart techniques, okay, which you can use to solve any circuit, right? So this was the basic thing that I have discussed. अब आप सारे क्वेश्चन कर सकते हो PYQ के, right? In fact, these concepts will be also useful when we will talk about transient, okay? If any power or energy concept is discussed in case of capacitor or inductor, so these concepts are very useful. ठीक है? In generalized understanding I have given you. Now we will talk about power and energy in a current source. So this will be the last topic. So power and energy in a current source. I'm pretty sure that when you will see the question in the gate examination, previous year questions or future questions, you will see the framework also. Whatever I told you, the similar statements, similar sentences, similar, you can say, circuit will be given also. Okay. So you don't have to now, the moment you see the question, you will be able to identify, अच्छा यहाँ पर ये करना है. Here we have to do this, right? Okay. So in this manner, your preparation should be like, okay, like it should not be like that. See, India played with New Zealand. I study, but India thought that is a final match for them, right? ऐसा नहीं है कि वो चलो यार ये तो फाइनल नहीं है, let us, तो बाहर हो जाएंगे फिर. So you have to live your day every day. Suppose you are chasing some goal, right? You have to live each day as a final day. कि मतलब हमारा tomorrow is the main exam, right? ठीक है, मतलब tomorrow is going to be a main exam, so you have to prepare like this. ऐसा नहीं है कि थोड़ा सा पढ़ा छोड़ दिया, right? Suppose this is a current source, you can say I equal to I naught. Some constant current is flowing here, and the voltage across this is V, and the current is nothing but I. ठीक है, current is nothing but I. Now, so this is very important. So suppose current is positive, the current is positive like this, and it is constant, I versus V if you see. So as long as these here the power is gonna get absorbed, I can talk directly. Here the power will get delivered. Okay, delivered. Why delivered? Because you are in second quadrant. Deliver. Now, as long as the suppose current is like this, okay, you can say I naught dash. Okay, here the power is absorbed. Here the power is delivered. So I think you should never think, okay, you can directly do it, because I've told you the quadrant wise where the power is gonna get absorbed and the power is. So don't be blind, okay, while solving the question. Okay. So let us take. Suppose we have got a question here, right? So suppose this is the resistance, okay, and the resistance value is nothing but 5 kilo ohm, okay? And the current source is there, right? Single current source, you can say 1 milliampere. Always see how many current sources are present also. So the voltage across this you need to know V1, and the current you should know I1, right? Current you should know I1, and the voltage across this. See, whenever you want to find the voltage, sorry, power, right? You need to know voltage as well as current, okay? Across and through, right? So across voltage, through current, right? Across voltage and through current. Understood? So this is very, very important to remember. Now, so here, if I ask what is going to be the, okay, so 1 ampere is going to flow here. So current is 1 ampere only. You can say 1 milliampere. And the voltage is nothing but 5 into 1, that is 5 volt. So voltage 5, current 1. So power is going to be what? Power. And power will be absorbed here. The power will be 5 milliwatt. Okay. Now, and if someone is going to ask you what is this, so here the voltage across this is nothing but 5 volt only, right? So you can find out the power here. The power is going to get delivered, right? It is delivering power. It is delivering power. How much power it is delivering? You can say 5 milli. See, this guy is dissipating power, right? So from where it is dissipating power? Somebody is there who is energizing the network, right? So somebody is delivering power and somebody is, wasting power, you can say, right? So it happens in the life also, right? Like our parents earn a lot of money, right? I mean, they earn not lot, you can say, but they earn to manage the livelihood of our, like they can manage our education or something, but we waste money sometimes, during our BTech days, or I hope this makes sense, right? So somebody is delivering power, somebody is wasting power, right? Like this, you can. So the power, energy conservation, power conservation, you can always think about it. So if there is only one source, okay, and rest of the network is like eating power only. Suppose there is only one source in your family, your father is there. Entire a member is not working, they are just absorbing energy. What will happen? Right? You can think like that, okay? So suppose you have got the situation of this kind. Suppose this is kind of a black box, and there is one network, one resistance. I mean, only resistance is present, and there is only one source, that is a current source. So what this current source will do? This current source will deliver power. When this current source will deliver power, then only people can, okay, maintain their hunger and all, right? Okay. Otherwise, they will be always hungry only. If everyone is absorbing power, so who is going to earn the money then, right? If there is only one source, if there are multiple sources, yeah, fine. Someday you can also have a party, right? Someday you can also have a party, right? ऐसा नहीं है कि बस ठीक है. तो आपको ये समझना है कि ऐसा नहीं होना चाहिए कि आप हमेशा कंफ्यूज रहो. इसको भी आप इतना टफ ले लेते हो. मतलब आई हैव सीन मैनी स्टूडेंट्स, राइट, दे टेक कॉन्सेप्ट्स वेरी हैवली. और कोई टीचर अगर पढ़ाता है तो उसको और कॉम्प्लिकेट बना देता है, राइट. यू हैव टू अंडरस्टैंड दिस, राइट. ऐसा कुछ नहीं है, बस आपको समझना है कि व्हाई. डोंट गो बाय द फॉर्मूला काइंड ऑफ थिंग, राइट, कि अच्छा V इक्वल टू पावर इज प्रोडक्ट ऑफ, या इट्स फाइन, बट व्हेन डिलीवर, व्हेन एब्जॉर्ब, think about the situation. If there is only single source, if there is a single source, so it will deliver the power always, right? It will deliver always the power. I think this is clear. But if there are multiple sources, you can say voltage source, current source. Suppose this is going to be a network, you can say kind of family, okay? This is a family, you can say family of resistance, okay? And there are many sources, right? Many people are there who are earning money, right? So everybody can earn, right? Yeah. Like initially our parents take care of us. In future, once we'll get job, we also start taking care of entire family, right? So you can think about that. But there are many sources. There are current sources. There are voltage sources, right? Okay. So some could be absorbing power, that you have to remember. Some could be absorbing power. Some could be absorbing power and at least one would be delivering power. एक बंदा तो होना चाहिए ना, एक बंदा. he should deliver the power. नहीं तो लाइफ में फिर क्या करोगे, है ना? ऐसा नहीं है कि सब लोग पार्टी कर रहे हैं तो फिर हो गया, ठीक है. आई होप दिस मेक सेंस. सपोज यू गाइज आर स्टेइंग इन बैंगलोर, राइट. तो बैंगलोर का कल्चर ही होता है कि मतलब पीपल हैव अ पार्टी ड्यूरिंग वीकेंड्स. अब मान लो सारे फैमिली वाले पार्टी करते हैं कि, और कोई बंदा ऐसा नहीं है जो थोड़ा सा काइंड ऑफ मेरे जैसा हो, राइट. so what will happen? Understand? I think this is clear. So at least remember, at least once would be delivering power. ये common sense है. At least one would be delivering power. Sometimes आपका common sense से भी question solve हो जाता है. So in my case, I always learn from you guys, okay? I learn from you guys. Whenever I teach, I learn from you. कि मतलब आप लोग भी कुछ कॉन्सेप्ट मुझे दे देते हो, तो ये बहुत ही अच्छा लगता है, ठीक है. I think this is clear. Okay, so please remember this. Now, this is all about situation. From the next class, I will start circuit analysis. In circuit analysis, we are going to talk about two things. One is nodal analysis, and one is the mesh analysis. And then theorems, two-port network, and transients, and phasor and all. So you see here how we are moving ahead, right? So possibly from today onwards, I might start signal and system also, so that we can bring variety into our experience, right? So don't worry, still we have a time. Whatever subject we will finish, you're going to get complete marks. Thank you so much for today.